All right, so this one didn't go too hot on the last basics quiz. It requires you understand properties of logarithm. It's really not a hard problem, but if you have, it falls back on this. If log of ABC, you have three things in a logarithm. It's broken apart through addition. So that's the idea here. So I have a 50 in here, and let's think about how I might make a 50. A log of an unknown base of 50 could very easily be a log of 5 times 5 times 2. And if you don't know 5 times 5 times 2 is 50, we have an issue, and you are the issue, all right? So I can break that apart into the log base A of 5 plus another log base A of 5 plus another log base A of 2. And then I can just write down the stuff. Log base A of 5 is 1.903. There's two of them. And then I got log base A of 2, 1.025. And then I just do the addition. If I take 1.903 and 1.903 and put them together, I get 3.806. So it's 3.806 plus 1.025. Carry the 1, 3, should be good. 4.831. There you go. Not a hard problem. Really not. In order to do number 11, the bases have to be the same before you can worry about the exponents. There's a theorem. It says if this is true, then it's actually not, well, it's a theorem still. Then x is y. So I need this 16 to become a 2 because I want the bases to be 2's. 16 is 2 to the 4th. Leave the exponential stuff right where it's at. Oops. I don't know why I wrote 2x minus something. It's 2 minus x. There we go. Since the bases are the same, I can I don't throw them away, but I don't worry about them. So x plus 1 must equal 8 minus 4x. And then x is on one side, numbers on the left, on the other. X plus 4x is 5x, 8 minus 1 is 7, x is going to be 7/5. There's only about 3 or 4 of you that are consistently getting that right, and that's not good enough. Find the domain of this function. So yeah, it'd be cool if you had a TI-84 on you. I know that t squared plus 5t plus 4 must be greater than or equal to 0 because I have this theorem, the square root of anything is greater than or equal to 0. I know that factors is, I'll use x as x plus 1 and x plus 4. And I can't just say negative 1 is greater than, right? I can't just do that. What I can do is I can plot points and I can test. I don't know why I'm going that way. It'd be this way. So there's me a number line. What I want to do is I want to check left, middle, right. So I'm going to check x equals negative 5. Plug in a negative 5. Let's see what happens. I'm going to have 25 minus 25 plus 4. I'm going to have square root of 4, which is 2. Now, is 2 greater than or equal to 0? You bet your butt it is. So this stuff is valid. Something between negative 4 and negative 1. I don't know, negative 2. And see what happens. I will have 4 minus 10 plus 4. That's a square root of negative 2, which isn't even real. It's the imaginary root of 2. This is nonsense in here. Now I'm going to check something to the right of negative 1. So I'm going to check a 0. If I plug a 0 in, 0, 0, and 4, I get root 2, I get root 4, which is 2, which is greater than or equal to 0. So I get to keep everything to the right of negative 1. So what I got to keep is I got to keep negative infinity to negative 4 with a bracket because we have the equality symbol. And I got to keep negative 1 to positive infinity. By the way, knowing brackets and parentheses is going to make a question like this 50-50. I swear it will. It will make it 50-50 if you understand brackets and parentheses. All right, so 13 is going to work a lot like that 10. It's just the other way around. Well, actually, no, you're kind of condensing it. So we have a log base 2, and inside that thing is going to be x minus 2 times x plus 1, and it equals 2. We're going to do log as base, argument, exponent. 2 squared must equal this product, which is x squared minus x minus 2. And 2 squared is 4. We're going to shift it right. X squared minus x minus 6, which does factor. Takes an x and an x squared, x squared. It takes a 2 and a 3 to create negative 6, and it takes a negative 3 plus 2 to create the negative x in the middle. If I use the ZPP, I get x is negative 2 or x equals 3. Now, if I plug that negative 2 in there and there, I'm going to be taking the log of a negative 4, which is a no-no, right? So this guy is extraneous. This guy is real. It's the only actual solution to the whole blasted thing. 14, easy peasy problem. The opposite of squaring is square rooting. When you take the square root, remember, two answers, plus or minus 8. X minus 5 is plus or minus 8, so x is 5 plus or minus 8. 5 plus 8 is 13, or 5 minus 8 is negative 3. All right, only about half of you guys got this one. They both contain an x. And there's going to be 3 answers. There's 3 solutions. Not that freaking hard. ZPP kicks in, x is 0, or x squared minus 25 is 0. That's an easy one. Soup 25 to the right, take the square root. Don't forget the plus or minus symbol. X is plus or minus 5. So easy, but missed by so many of you because you just don't care. 16, we have a cubic root. First thing we do is we play the isolation game. We get a 6 on the right. Cubic root of 6x plus 2 is equal to 6. The opposite of cubic rooting shall be cubing. It always has been and it always will be. 6 cubed is 216. If I cube a cubic root, I get the quantity inside. Subtract 2, 6x is 214. Divide out the 6. That'd be 107 over 3. And it will reduce farther too, won't it? Yes, it will. That'd be 39. All right, 17. I was surprised that about 3 of you missed this on that previous basics quiz. It really shocked me that you missed it. You weren't supposed to miss it. You'll have 4x minus 24 equals negative 8x, or sorry, not equals, minus 8x plus 20, and that equals x plus 6. This is the one you're not supposed to miss. It's probably going to be the first problem on your challenge exam. I mean that. It's probably going to be the first problem on your challenge exam. If I put these two together, I'll have a negative 4x. Negative 24 plus 20 is minus 4. Still equals x plus 6. That'll give me negative 5x equals 10. X is negative 2. Assuming I didn't make a mistake myself. I don't feel like I did. So I'm going with it. 18. Doesn't factor. There are no factors of 8 that add up to negative 1. So, and this is one of those, man. Like, a third of my pre-calc kids miss the quadratic formula. Why are you in pre-calc? It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. Just feed this thing. B is negative 1. So 1 plus or minus square root of a negative 1 that is squared minus 4 times a, which is 1, times c, which is negative 8. All sitting pretty over twice a 1, because a is also 1. Inside the square root, we have 1 plus 32, which is 33, all over 2. That's not hard. Not hard at all. 19. Earlier I mentioned this property, a base to the x equal a base to the y. X is y. So I have that property right here. X squared must equal 13x minus 12. x squared minus 13x plus 12 is 0 because we want to use the zero product property. That will factor. It takes 12 and a 1, and they're both negative to get to a negative 13. So my two x choices are 12 or 1. They should both work, and they do both work because I just checked them mentally. 20, find two positive and two negative coterminal angles for 110. It's plus or minus 360. All right, so if I do 110 plus 360, I think I'll get 470. If I add another 360, there's one answer. 830. And then I do 110 minus. Why is this thing not writing? 110 minus 360. That's going to be negative 250. Take away another 360. What's that going to put me at? 610. All right, 21. If the arc length of a sector is 8 pi centimeters and the radius is 30 centimeters, find the measure of the central angle in radians. So I have this little formula that I can fall back. It's S equals R theta. Only about half of you know it based on the quizzes. You know, Daniel, Taylor, you know it. I don't know if Caden knows or not, but maybe you ought to get on that. Plug some stuff in. There's 30. There's S. It's 8 pi equals 30 thetas. Divide out the 30 and you'll be done. Especially if you can reduce a fraction. That's going to both divisible by 2. That's going to be 4 pi over 15 equals my angle. Such an easy little quiz. Like it really, really is. Get your crap together.